So I'm gonna ask for some participation here. So give me what you got on your BCE. One, right? Because silver is number one. Yields. NO3, 2. So copper 2 nitrate in. Ag solid, right? Balance. So 2 on the silver nitrate and 2 on the silver. Okay, so if your BC is not right, fix it because that's going to affect your mole ratios later. So then what was your next step? Or tell me quickly, I hear you. 2.5 grams of copper, what'd you do? Okay, so you converted to moles of copper, 63.55. What was that in moles? 0.0? Is that it? 4? I just wanted one more. Okay. All right, so then what'd you label that? Have, because it's very important to be able to find stuff on your paper, right? So that's how much you have of copper. Yeah.
So I thought it was copper 2.
It's called copper 2 to indicate the charge to you, but it's straight up copper solid. Okay, so then what was the other one you had to do? Hold on, I need to do the same thing for silver nitrate, but how do I use those numbers to get that? And then multiply, and then what cancels? Liters, and you get moles. So molarity is that whole mole per liter thing. So 0.400 liters times, what was the molarity? 0.10 moles of silver nitrate specifically per 1 liter of that solution. So that allows for liters and liters to cancel, giving us 0.04, no, 0.004. 0.004? Huh? 0.04, okay, so 0 moles of silver nitrate. What's up? Is this right? What's the numbers? That's what. Yeah. So this is liters. I went straight to liters. I didn't even write down the milliliter mark. So this right here, oops, sorry, label this half of silver nitrate. Okay, so once you got to half of both of them, then you stopped and you said, okay, I have to compare them. And when I compare them, what do you compare them with? Mole ratios. And this is going to tell me how much I need of the opposite reactant. So basically, if I have that much copper, I need a specific set amount of silver nitrate to fully react all of it, because it reacts in a 2-to-1 ratio. So how do I indicate that here? How did we do it yesterday? Times 2 moles of, because that's what it says here, 2 moles here, over 1 mole of copper, and that gave us how many moles of silver nitrate is needed in this with this amount of copper that we have. What's up? 0.078 moles of silver nitrate. 0.078 moles of silver nitrate. Okay, so then you stop and you reflect. If I need this much silver nitrate, and I have that much silver nitrate, what is your conclusion? Do you have enough? No, you don't have enough. So what's going to happen? Right, it's going to run out. Therefore, it's the limiting reagent. Right, so I like to label that up here, LR in excess, to make sure we don't forget. Once we worked hard to get there, you don't want to forget what it is. But then let's just double check on the other one for the need of the other one, just to make sure that we're on the right track here. So how would I adjust this to see how much I needed of the opposite reactant, the copper? So flip the ratio, right? So I did 2/1. Now I'm going to do 1 mole of copper required for every 2 moles of silver nitrate. Sorry, I'm writing this kind of down here. I'm running out of space. So that tells me that I need, anybody? 0.020 moles of copper, and that's a need for copper. So then if you look, you only need 0.02 moles of copper. How much do you have of copper? A lot right here, 0.0399 or 3934. So you're comparing copper to copper. So you have a lot more. So you're like, oh yeah, I got plenty of that one. I got excess. Yeah.
Does it also have more than one reagent in the reaction?
No, mathematically, no. But you can also, you could have something where it's stoichiometrically equivalent, meaning you have exactly the same amount of have and need, so they both run out at the same time. So I guess, yeah, you could say you have two, but I just say they both run out at the same time. Okay, so now we know who the LR is. So that whole process was just to figure out who the LR was, so we could figure out how much silver can be recovered from the reaction. So how do we start on the next part? What do we start with? What is our given that we start with? The limiting what? Reactant what? Moles. Okay, so where's the limiting reactant moles? Which one? Say again? This one, right? Okay, so I'm starting with that. 0.040 moles of silver nitrate. So I told you the beauty of finding the LR is now you know to start with for the rest of the problem, the rest of your life here. Okay, and I want to get from silver nitrate to what though? What's my question? So when it says how much silver, what is it really asking? Grams of silver. So sorry, I have to keep scrolling up and down. So the question is grams of silver. All right, so that's my question. Get me there. Go for it. Shout it out. I'm ready. One mole. What's the ratio? I think it was 2 moles of silver, right? My BC is up top. I'm expecting you guys to tell me the right ones here. 2 moles of silver over.
Don't you want them to cancel?
It's 2 to 2, right? Where are you guys pulling ones from? 2 moles of silver, 2 moles of silver nitrate. What's your question, Lizzie? Okay. This is straight from the BCE. They did the pumpkin yesterday. So once you get to moles of silver, then where do you go? Grams of silver, which is molar mass. Thank you, Hayden. What is it? 107.9 grams of silver per 1 mole of silver. Nerd. Okay, so there we go. All of our moles cancel. We get to grams, and somebody calculate number of grams that is. What's it? What is it, Zach? 4.3 grams of silver. I'm hoping you did. That's a lot of silver. That's worth some money, right there. And I will usually precipitate out silver and sell on the black market to supplement my teacher salary. I'm just joking. I don't do that. I don't. But I have collected silver. I have it in like a little jar after we precipitated it out in electrochemistry. I'll show you guys later. Anyway, it's really pretty. All right, so next one. How much of the excess reactant is left over? Who's your excess again? The copper. The copper, how much do I have of the copper? And how much do I need of the copper? So that's a 2. That's 0.2 right there. There you go. 2. So then you said have minus need to give you excess left over, right? So then have was 0.03934 moles. Subtract the need, that was 0.020 moles. So that's 0.01934 moles of copper times molar mass, 63.55 grams per 1 mole. So I'm just going ahead, go into mass because it says how much of something. Yeah? Grams of copper. Okay, so that's like, let's see here. How many sig figs would I need? There's 3 decimals. So that would need to be recorded 3 decimals, which would only be 2 sig figs, so then 1.2 grams of copper. Okay. So we've done the LR. We'll use the LR moles to find precipitate of silver. Then we use the have and need of the excess reagent to compare them to figure out actually how much was left over, which is a good amount of copper. So copper is expensive. That's like wasted copper. Horrible idea. Okay, last question. What is the percent yield if 3.64 grams of silver is recovered from the reaction? So what is percent yield again? Hayden. Times 100, right? So Jalen, tell me what is this number given to us then? Because I actually have to give you that number, right? I actually have to put it in the problem. So remember, 3.64, write it down for me because I'm going to forget what it is. 3.64 grams. So what do we need to do, or what have we already done? What is, so the theoretical yield was, no, we're talking silver. It's a product. Right, we've already calculated in La La Land, if we had this much LR, if everything was perfect and it reacted appropriately and we made enough silver, it would have been 4.3 grams of silver made. So that's already theoretical yield. We got it. We just got to take these numbers, divide them, and we're done. So what was that number again? Actual yield? 3.64 grams of silver over theoretical yield, which was 4.3 grams of silver. Notice they're in the same units. So grams of silver, times 100. What's that person's yield? Ooh, they're so close. Oh, 84.65? Oh. Oh, I'm rounding that baby up to 85. They are a accomplished chemist. Woo! Okay, so just FYI, we will have a quest test. It's a longer quest, so it's like a test. On no, not Tuesday. I moved it to Wednesday. So Wednesday we have something related to this. Okay, so what have we learned since our last quest? Balanced chemical equations.
Okay, we did.
Okay, lots and lots of okay. But hold on, lots of reactions, right? Your foldable should be probably done by, I would say, Tuesday for sure. Because Tuesday, I mean, there's nothing new happening here. You know what's going on. So know how to predict your products. You've got just around like general stoichiometry with reactions related to VCEs. You got new stuff with LR, and what did we just calculate? Percent yield, and that little thing about molarity. Yeah, that was one extra step. Yeah. Okay, so we're gonna do our lab now. Tuesday when you come back, I'm gonna talk about the last topic, which is like 20 minutes, and then Tuesday is gonna be our review day, and then we'll have a quest test on Wednesday. What are we doing tomorrow? No. It's called stoichiometry, people. It's stoichiometry. Okay, that is tomorrow. Yeah. Wednesday? Maybe that's why I planned for Tuesday. You guys just have to come. No, you guys just have to make it up. I can't push it another day.
Maybe we should do it.
I can't push it another day. Okay, give me your full attention. We're going to jump into the lab, but I need you to have a piece of paper out. Title it Mole Mass Relationships. Mole Mass Relationships. So here's what the lab looks like in your lab notebook. So just look up here and I'll tell you what you're responsible for. I'm going to kind of tell you the flow of this so that you get this maybe done whenever we get back there. You're going to read a little bit, take like less than 5 minutes to read about the background. It gives you a reaction. That reaction may or may not be balanced. You need to double check that. Okay? As you're reading, you got your, I already have a lot of the materials out. I just don't have the gas on yet because I'm not going to turn the gas on until you do the pre-lab question, which requires you to figure out how much of another reactant you need to react with this other reactant. Picking up what I'm putting down? Yeah. You're going to have to calculate how much you need of something from something you have. Okay, so that's the hydrochloric acid in this case. So it tells you kind of how to prep. So maybe while one person's prepping the lab by getting the evaporation dish and everything taken care of, massing it, another person's going to read, 2.5 grams of sodium hydrocarbonate, aka sodium bicarbonate, thank you. And that's going to be what you record. So maybe one or two people can work on that. But then it says, before you move on, answer pre-lab questions on your data sheet. That's what I need to see before you really start the reaction. Here's what the pre-lab questions look like. What products will be left in your evaporation dish, blah, blah, blah. Number 4 is specifically what I'm going to look at. Calculate the volume of 6 molar hydrochloric acid that will need to react completely with the mass of sodium bicarbonate that you obtained. How much sodium bicarbonate did you obtain? How much sodium bicarbonate? 2.5. Okay? So that's what I need to see first. Divide and conquer. Logs in the lab notebook. Get your safety glasses. Be careful. I already have the evaporation dishes and the watch glasses hanging out up there. Okay? Let's go. Find it. Can I turn on the gases real fast? Bring your stuff with you. Bring your stuff with you. Yeah.
Ella, are you going for teal today?
I am.
For 86.
Oh, I put it in anyway, but I'm like crazy again. You will need your calculator. Same lab groups as last time. Same areas as last time. Don't get too creative on me. I got it late and I was like, never clean something late. I'll fix it. I usually am aware of when stuff's turned in, but I didn't get it till the next day, so I didn't pick it up. I'll fix it.